Okay, so if you are doing an NPTEL DBMS course, so I'm going to take you to the assignment one. Its questions are very nice and we should do it. Yeah, it will help you out for your exam also. So let's see them one by one. Uh, what are they? Okay, so there are 10 questions in assignment one that we are going to do one by one. Okay. Question 1, 2, 3 are about abstraction key schema instance. Question 4 will be about super key and candidate key. Question 5 is algebra, which we are going to have it for in our further lectures. It is about to come, and yes, in SQL we are going to use that algebra join, and that we have already done. Yes, question 6 will be about SQL DDL versus DML. Then referential and entity integrity. It is about to come in the further lectures. Then selection and projection in algebra. That we have already covered up. So let us see one by one all the questions. So the question one. Okay, let's see this one. Question one is, and it is a, I would say it is a trap question. Okay, it is a tricky question. The thing is, once you will read this question, you will think it like it is talking about out of three levels, it is talking about the physical level, but it is not. You have to concentrate on that one point which is given in the question. Okay, so that's why I am calling it a trap. So here the question is, let's read the question. Which level of abstraction? So it is talking about the three level schema diagram, three schema diagram. Okay, three schema. So in that one we have three levels: external, conceptual, or logical, and last one is internal or physical. So these are abstraction levels. Yes, levels of abstraction. So the out of these three levels, we have to choose one of the one which has been described over here. It describes the types of data stored in the database. So first thing you will observe is data stored in the database, which happens in the physical level. But that is not the correct answer. You have to see the types of data. Types of data are stored in the logical level, not in the physical level. So that will happen, that check will happen in the conceptual level. So that is the trick given over here in this question. Okay, so that is the thing. So let's see what is the work of these four levels one by one. It will be a revision also to you. So our answer is logical level. So what is the work of physical level? How data is stored, the files, indexes, bytes on the disk, where the data is given a space in the disk. That is all about physical level. Logical level is what data is stored and its structure. Yes, so it's schema, its types, tables, columns, relationships. So I told you, whenever we are checking about any query which is going further in the processor query evaluation engine, it will be checked whether that table exists there or not, whether that column exists there or not, and along with that it will check the type also. Yes, so the types. Yes, so that is a data type. That's why our answer is logical level. At view level, that is external level, how individual users see a slice of the data. They are sitting at the external level, the topmost level. Okay, so that is the thing. So types of data plus structure, that is the logical level. I hope you got the answer. Yes. Okay, fine. Let's move to the next question, second question. So question number 2 is this one. We have to identify a valid primary key for course registration. Very nice question it is given. We have already discussed about primary key. Yes, so the table is course registration table, and it is having this schema is given to us. Yes, it is having some attributes like student ID, course ID, semester, and grade. Student ID, course ID, semester, and grade. And it is given with some data inside it. Some entries are being given. We have to choose which one is the primary key. So primary key is the one which uniquely identifies the entity. Correct. I hope you remember this definition. So here, if you will observe student ID, you can see here 101 and 101. Repeat. Yes. So can it become a primary key? No. All values are not unique. Not unique. All values are not unique. So it cannot become a primary key. No. Then you will check course ID. So here CS101, CS101, repeat. Again CS101, repeat. So again, it is not unique. Not unique. It cannot become a primary key. So then semester, again, values are repeating, duplicacy, not unique. Grade, again, values are repeating. So there is no column which is having the unique values inside it. Then what will you do? What is the scenario? Then what you have to do? You have to check out any two of the columns which can be combined together and make it unique. Okay, that is the thing. So that is our next step to choose a primary key. Okay, so what we will do, let us check in our options. So student ID cannot be an option, course ID cannot be an option, alone they cannot become, semester cannot. So we are only left with one option. So in this way you can find out your answer, but let us see the explanation. So student ID and course ID, let us take these two. Okay, so what is happening if you will take like this 101 CS 101, that is first value, that we are combining two columns values. So second one is 102 CS 101. So here this duplicacy which was happening in the alone column of course ID, now it has been resolved. So together it is unique. Together it is unique. They both are different. Yes, they both are unique. Then in the same way 101 MA 101. So this repetition 101 in the first column of student ID, now it is being resolved when we are combining it with course ID. Now all these are unique to each other. Yes, they all are unique. Then 103 CS 101, again unique. Then 102 MA 101. That's why if we are combining any two attributes together and they're giving us unique entries, then yes, it is a primary key. It is a primary key and it is called as a composite key. This concept is called as a composite key. Please remember this. Okay, so that is the thing. So that is your answer for this one. So let us see. This is an explanation. Alone, they are not unique. Not unique alone. Not unique alone. Student ID and course ID, it is uniquely identifying each. That's why. That's why it is a composite key and it will act like our primary key here. Okay, so that is called as composite primary key. You can see that is called as composite primary key. So that is your answer. I hope you got it. Please drop your comments for any doubts. Okay, let us go further to question number 3. This is the question number 3 of the assignment. So here what is happening? Identify the correct statement about schema and instance. So I hope you remember what is schema and what is instance. So schema is a structure of the table. Yes, that is a structure of the table. So and instance is what? It is a snapshot of a particular current picture of your database. Yes, that is a snapshot or screenshot also you can say. Yes, so what is happening in this one in question 3? So here, if you'll check this one, employee ID, employee name. It is not an instance. It is written as it is an instance of a relation. No, no. It is a schema. It is a schema. Okay. Yes. Then employee ID, employee name. It is an example of physical schema. No. It is an example of logical schema. It is a logical schema. Okay. So again, no. It is a schema, but it is not physical schema. It is not talking about the storage. Yes, so physical is the storage part. No, it is telling about the structure of your table. Yes, so it is not at all related to the physical level. Yes, yes, and also it is not an instance. So here it is wrong. Here it is wrong. Now here if you see, it is talking about the values inside the employee ID and the employee name. So that is a current picture. Yes. So of the relational schema, it is yes, it is an instance of this relational schema. Yes. And then if you say this one, the values inside the table, the data basically is a schema. No, it is not a structure. So logical schema is our structure. So it is not this thing is not a schema. It is an instance. It's an instance. So only the C statement is correct over here. Okay. So this is an explanation over here given to you again. So whatever we have discussed, the thing is in the same thing. So it is defining the structure. It is a schema. This is the actual data in the row, which is an instance. So this is an instance of the relation schema. So that is a correct statement. I hope you got it. So schema and instance, very, very important topics for your exam purpose also. So let us go further, move to question number 4. So what is question number 4? We are given with some schema over here and we are given with some super keys and we have to identify a candidate key. So this topic is not yet came in our lecture series, but it is about to come very soon. Okay, so let us see this question because the due date of the NPTEL assignment is there. It is 5th of August. That's why I thought to discuss all the questions. Yes. So as per the request of the students also, yes, we should discuss it. So let us see. We are given with the schema over here. We have one table, bookstore. The name of the table is bookstore and its attributes are ISBN, title, price and category. Correct. Yes. So what it is telling us, it is having some super keys given. ISBN, ISBN title, price, and category. That is given to you. Okay. And yes, one more. Price, category, and title. So you have one, two, three, four super keys are given to us. We have to select the correct candidate key. We have to select a candidate key. Okay, that is the candidate key. So what is candidate? Already super keys are given to us. We have to select a candidate key. Hmm. Okay. Now, what is candidate key? Candidate key, it is a minimal. It is a minimal super key. That is a definition. So, for this question, that much is enough to remember. Okay. What is candidate key? It is a minimal. It is a minimal super key. Candidate key is a minimal super key. Yes. Now, see. Let's see one by one. Okay. So, ISBN. ISBN is a super key. So, let us take all super keys one by one. Okay, then you will get the answer. So our first super key is ISBN. It is given as a super key. So minimal means we have to reduce it further. So it is individual one. We cannot reduce it further. It is already minimal one. So yes, it can be a candidate key. It is candidate key. Okay, can be a candidate key. Now let's take second one. ISBN and title. Yes. So what will be the minimal one? Out of them, we can divide it further as ISBN and title. Those will be the minimal ones. Yes. So ISBN is already there in the option and we have already chosen it as a candidate key. So these two can become candidate keys. And title can also become one candidate key, but it is not given in the options. So that cannot be our answer for this question. Yes. But yes, title can be a candidate key because it is a minimal form of the super key. Now next, let's take third one. That is price and category. So price and category. Yes. So before that, you have to see that we have its further form is also given as our super key. That is price, category, and title. Okay. Yes, that is the thing. So now we have to check what is a minimal one out of them. What is a minimal one out of them? Correct. So what will be the thing? Hmm. See here. Price and category. Now here the thing is price and category alone cannot become a super key. Yes, it is not given as a super key. So that we cannot further reduce it and make it as a candidate key. Yes, they are not alone given over here. They are given in the form of a together, price category together. So how it has been divided? Price category, which is already given as a candidate super key, one, and the title. So this one, this is already given as a super key. Yes. So this one out of them will become our candidate key. The minimal form. So its minimal form is already given. Yes. So its minimal form is price and category together is given. Yes. So we cannot further divide it. as price separate and category separate because it is not given to us as super keys. If it would have been given like ISBN as a super key, then only it can become. Same goes for title because it is not given like the same information. Title is not given here as an individual super key, so it cannot become a candidate key. But here, if we will divide price category and title, price category is already given as a super key, so it can become a candidate key. The minimal form which is already available in the super key, it is can become a candidate key. So price category now can become a candidate key. So we have two answers for this, ISBN and price and category. So that will be our answer. So let's see it further. So candidate key is a minimal super key. So there should not be any removable columns. Yes. So answer will be ISBN price category. ISBN is already a super key with nothing to remove. So yes, it is a candidate key. ISBN title contains ISBN. So it is not a minimal. It is not a minimal one. Correct. Yes. Because already super ISBN is given as a super key. That's why. Okay. I hope you got this point. For any doubts, please drop your comments. So price category, it is a super key. Neither alone is a super key given. So that's why price category can become a candidate key and it is a minimal of the total one, price category and title also. Yes. So price and category alone are not super keys. So they cannot become a candidate key. I hope you got this answer. Yes. So please remember this. In my further lectures, this topic is going to come very soon. So let's go further and check out question number 5 now. So question number 5 is about our relational algebra. So it is asking us what does this expression represent? Okay. So as I told you in my lectures, how you can write it. So what it is telling us, so here the selection is happening first. So in selection, what we are doing, the citations should be greater than 50. Okay. The citation should be greater than 50. Okay. From article, first thing. And then second selection is tag should be AI from the article tag. That is the thing. And we are joining them. So that means we will be taking the common values. And finally, we want to just project AID. That is the thing. Okay. So join keeps only AIDs that appear in both of them. It will keep only those AIDs which will appear in both of them. So first selection of citations of this condition will happen from this table. And then selection of this condition will happen from this table. Correct. So select citations greater than 50 will give high citation articles and select tag equals AI will give AI tagged rows. That is happening in this first thing. Yes. And it will display only those ones which is having AIDs common in both. Both means which operation? And operation. Both means it happens in both. Both means which operation? And operation. Now this will help you out to choose the correct answer. Okay. Yes. Okay, fine. So it's articles with more than 50 citations and tagged AI. So that only matches with one of the options. AID of articles with okay, but it is not talking about the tag AI. So it cannot be your answer. AID of articles this or no. We have already um, checked out and it is and because it is talking about both. If it will be either this or that, then it will be or. Yes, but it is not that. And it is not a not operation also. No, no. So all three are ruled out. Only one option left where and is mentioned. AID of articles with greater than 50 citations and tag AI. That is the thing. Because joins works on the common things which is appearing in both. So natural joins works in that way only. And we already discussed it. So it is a symbol of natural join. I hope you got this answer. So let's see the explanation of this one. That is the thing. So AID of articles with greater than citations and tag AI is the correct answer. It cannot be articles with more than 50 citations. It is not talking about the AI ones. Here it is talking about OR ones. The second one, the third one, the join keeps only AIDs present in both. That is AND operation. So I hope you got this answer. Let's go quickly to question number 6, that is insert versus alter table. So it is a direct question of DML and DDL. Okay. So which one belongs to which one? So insert is a command which changes the data inside the table, which is a manipulation, which is manipulation of the data. Yes. And second one is alter table, means it is changing the structure of the table. So which is what? DDL, definition language. So it is a direct answer. So S1 is S1 S2 both belongs to DML, directly rule out. So insert belongs to DML and alter command belongs to DDL. It is a direct answer. So there's nothing much to discuss over here. DML, we are changing it. We are making some changes. Both belongs to DML, ruled out. DCL, DL, no. They both belongs to DML and DDL. Insert belongs to DML, that is manipulation, and alter belongs to definition language. So that is our answer. Okay. Okay, fine. So that is the thing. Alter table changes the structure of the table. That is data definition. Insert changes the data inside the table. Okay, that is manipulation of the data. Let's go further to question number 7. So question number 7 is what? It is about a foreign key. So let's see what is happening over here. Department ID is given as a foreign key in one schema. So we have this employee allocation table. Inside it having some attributes. Employee allocation is a table name. It is having an attributes, allocation ID, department ID, and employee name. Okay. Department has D101, D102 only. Okay. Department has only two departments, 101 and 102. Which one is the valid instance? It is asking. Okay. So the thing is like, if the department is having only department ID, only two, we have only two IDs. What is D101 and D102? Only these two IDs, two departments are available. Then if I am talking about employee allocation and we are making it stable, suppose, then it is having allocation ID, department ID, employee name. Correct. Then what should be there? It is taking this department ID. Then this column can have only 101 or 102 values. Only 101, 102, only 101, 102. Only these combinations can come up. It cannot have 103 because it does not exist. It is not existing over here. Okay. So we cannot keep that department which is not at all existing. So that is the thing. So which one is the valid instance that we have to check out? So let's check one by one. So one is A001 D101 Amit. So that is the first one. So it has given some values. Let's take all of them. Okay. So two values are given over here. Let A A101, that is allocation ID. So you have to check this one. This value will give us the data. Okay. So it is telling us D101. D101 is existing. Okay. That is okay. That can be there. D105, it is not existing. It is not at all our department. So it cannot be our answer. Ruled out. So here, check out. Department 101, it is existing. Department 102, yes, it is also existing. So that can be one answer. But see one thing. Allocation ID, allocation ID. Here, it is being utilized same for both of them. No, it cannot be. Cannot be same for two people. Yes. So ruled out. Now see this one. See here what is happening. Department ID is a foreign key and here department ID is a primary key. Yes. Now see this one. Here allocation ID basically serving like a primary key. Although it is not given, but the values are given like that only. So it is duplicate also. So that's a ruled out. That's a ruled out. And here you see, here they have given null value in allocation ID. Although D102 is allowed, both can belong to one department. That is allowed. But here in allocation ID, it is null. No, not allowed. Now see this one. A1, A001, A002. No duplicacy, not null. It is valid primary key data. Then 101 valid because it is available in our department. D102 valid, available in the department. And names. So only this option is fitting as per all the rules. Okay, so that is a correct instance. That is a correct instance. Now see. So here primary key violation happened. Yes. Okay. Null entity integrity violation happened because primary key cannot be null. You have to assign some allocation ID. I hope you got this. Now let's move to question number 8. So question number 8 is about, suppose some data is given to you, region stats output keeps all columns but only rows with population greater than 50,000, greater than or equal to 50,000. So which operation is a valid operation? Okay. So we have to get what all columns kept means no projection. All columns kept means no projections required. That is the means. Okay, so in projection you don't have to show the projection. Projection will utilize if you have to project certain one column out of all of them. So all columns means here one thing you have to note down. Projection is not required. All columns means pi is not required because we are projecting everything. So we need only select operation. So in all the options we have only select operation. Yes. So now see, with select operation gives us the correct answer. Yes. So it is a question of pure selection. First thing, which rows will survive? Let us see. Here, see, greater than equal to 50,000. It is as per our condition. Yes. So it will fit. Greater than 60,000. No, it is not fitting to the condition. Now see, suppose I'll give you certain things. The thing is like, I'll give you this with one example. Wait. See this one. Suppose Texas is 70,000, California is 80,000, Ontario is 50,000, Florida is 6,000. So they are kept. Output will keep every column. So that we have already discussed. Which one will be dropped? Which one will be dropped? Quebec 45,000, Bavaria 30,000. Both are below 50,000. That's why they will be dropped. Okay. Now see this one. There's no mention of any country. So that is not required. Region stat should be our output. So that from that we are giving output. We are keeping all the columns, but only the condition is population should be greater than equal to 50,000. So there is only one operation which is fulfilling this as per our category. That is select population should be greater than equal to 50,000 from region stats. This will ruled out. Here there is no mention of country in the question, ruled out. And here not greater than equal to 80,000 because it will leave out the data between 50,000 to 80,000. So it will not work for us. So only one option is working for us, that is select population which is greater than equal to 50,000. That is the only option. Okay. Okay, next question, ninth question. Now here the thing is, wait. Yes. Okay. Okay, fine. Now it wants to check the output should be equal to the rows common to both region stats 1 and region stats 2. You have to imagine two tables, region stats 1 and region stats 2. Okay. And then you have to find out the common things. So common things, if you have to find out, there is out of all the options, only one set operation will work in that. That is what? Intersection. Yes. So minus will keep only the data of stats first table and it will remove the second table. Let me show that to you. So this one will do what? It will just keep this data. It will do what? Common to both. This one will do what? Stats 2 data only. And this one will do what? Complete data of both. So only one. We want both. This is our condition. So only this one is fitting. So that is our answer. Very easy. Okay. Let us see that. Yes. Okay. Fine. So in that question, that Texas and Ontario sum table is also given to us in the questions that I was unable to keep in this one. So you can check out in the NPTEL course if you are doing that. Okay. So let's see this one now. So yeah. So here what is happening? Output keeps only region name plus country columns and only population should be greater than or equal to 50,000 rows. So which operation will fit according to this query. So it needs two operations. Output keep only region name and country. So that means we are talking about projection here. So what is happening? So in projection, we'll have two things. First thing, region name, comma, country. First thing, so you have to check out of all the options. This is keeping both. So it can fit. It is not keeping. No, it is not at all utilizing projection. Ruled out first. Now projection, it is keeping both. Yes, so it can fit. It is also keeping both. It can fit. Now let us see the further thing. Now we need to select only those rows which is having population greater than equal to 50,000. So it should work like select population greater than equal to 50,000. Yes, that is the thing. So here it was already ruled out. So here it is not talking about selection at all, ruled out. Here it is talking about select population greater than equal to 50,000 from the table region stats. So yes, this works for us. And then project only region name and country. Again, it is projecting all the rows, not fit. So only C is the only option which is fitting up for the question. Okay. So that's all your 10 questions of NPTEL assignment. So this is the explanation for it. You can pause the video and you look for it. So that is all about our fully solved 10 questions of NPTEL assignment 1 2026. Okay, so course has just started in July, and this first assignment is due on 5th of August. So please, if you're doing it, I hope this video can help you out to understand certain questions. For any doubts, for any queries, please drop the comment. Okay. So the first question was a trap. You have to understand that types was written. That's why it will be logical level, not physical level. So thank you students for watching this video. Thank you for subscribing my channel. Keep watching, keep sharing my videos. Thank you so much for your support and motivation. Bye bye. See you in my next video.